Hello. How is everyone? Wow, 18 people. It's almost as if you care about your results or something, right? Poggers is banned, right? No, I'll say Poggers. As you can see, I'm eating some chips and fake nuggets. I don't know what they put in like vegan meat nuggets, but hey, that's what I'm eating. So you'll have to excuse my terrible manners at the moment. If I talk with my mouth full, it's only because I care about you guys. So, mushrooms, yes indeed. Not mushrooms, it's chicken nuggets. No, you're thinking of corn. Corn is mycoprotein. But I can't have corn because it's got egg white in it. I don't know what I think it's pea protein. I think they use pea protein for these ones. They're all right, man. Cost like less than £2 from Aldi, so use the promo code computer science is rad to get 50% off. Anyway, I figure that what we can do is yeah, they've got tons of vegan stuff at Aldi. It's great. Highly recommend. I figure we can go through some of that stuff. I mean, we went through a lot of it in the lesson today, right? But there was a couple of things in particular that I want to make sure make sense in everyone's mind. Namely, calculating file sizes for images, and also how to write a program which iterates through an array. Okay. Promo code will not work in the exam, unfortunately. It is not recognised. It's not recognised. I've also got a bottle of this incredibly upmarket pop. Belvoir sparkling apple juice. This is my friend who is let's say from a more well-off family than me. She needed to come round and have a chat about some stuff. And she said, do you want me to bring anything? I said, bring me a bottle of pop. Thinking that I would get like, you know, some bargain cola or something like that. And she brings around this stuff, which I could never afford in a million years. Will SQL injections work in the exam since you're a robot? SQL injections will not work. And the reason SQL injections will not work is because it's handwritten paper. So anyway, it tastes pretty good. It's good stuff. It's good stuff. It probably costs about 10 grand a bottle or something. Made with pink lady apples. So there you go. Right. So let's talk about images. Should we talk about images? Right. I would like to think that all of you guys know how images are stored. Is that right? Does that make sense? Do you know how images are stored? Could you explain how images are stored? If I gave you a question, explain how images are stored. Just drop in the chat what are some of the key words that you would use to describe the process through which images are stored on disk. I probably wouldn't, if I'm talking specifically about how bitmap images are stored, I probably wouldn't mention compression. All right. You are right in thinking that images, like JPEG images, obviously they are compressed. Out of interest, is JPEG an example of lossy or lossless compression? Lossy, yes, JPEG is lossy. Can you, for bonus points, right? JPEG is not lossless. We can tell it's not lossless because when you compress a JPEG image a lot, the quality reduces. Okay, lossless compression in images means that the compressed image looks identical to the uncompressed image. Can you give me an example of a file format that uses lossless compression? An image file format, that is. Yeah, PNG. Interestingly, in my year 12 class today, I was teaching the LZW compression algorithm, which is the actual algorithm that PNG images use, or at least I believe they still use it. But you'll get onto that if you do A-level. But let's help you get to A-level first. First of all, we've got this image here. Yeah? How many pixels are there in that image, and how do you calculate that without just pointing and counting? I might have to dash off and grab a fork so I can eat this salad. Get out of my head. What? That's not how you calculate how many pixels there are in the image. How do we work out how many pixels are in this image? We could count, but obviously, yeah, multiply the width times the height. Okay? Now, there is a word beginning with R. Hopefully you can remember it. That word beginning with R is what we refer to that width and height as. It's another way of saying how detailed the image is. What's that word beginning with R? I'll be back in a minute once I've got a fork. Yes, resolution. Okay, so the image resolution is how many pixels are contained within the image, usually with reference to the width and the height. Okay, so an HD image, for example, is 1920 pixels wide and 1080 pixels high. So if we want to calculate the total number of pixels in an image, we multiply the width times the height, right? So far, so good. I'm going to skip over to the next incredibly patriotic slide here. Look at that. What a perfect rendition of the British flag. There are... Now, this is interesting. There are 3 colours in this actual image. But over here, what is this referred to? This table containing multiple colours? What do we call that? Nobody knows. Yes, the colour index, right? The colour index is basically a list of all of the colours that are in the image. And they have binary values assigned to them, right? So in this image, 0, 0 is red, 0, 1 is blue, 1, 0 is black, 1, 1 is white. You will notice there are no black pixels in this entire image here. So 1, 0 will not appear in our list of pixel values here, right? But even though there's only 3 colours in the image, we still need 2 bits to represent each pixel. I hope that makes sense. If we had 5 colours, we would need 3 bits. Yeah? And there would be effectively 3 wasted spots in the colour index. Does that make sense? Just give us a thumbs up if it does. Meanwhile, I'm going to carry on. All right. So the number of bits, or rather the number of colours in the colour index, tells us how many bits we need per pixel to represent that colour. Because we've got 4 colours in this colour index, each pixel is represented by a combination of 2 bits. Right? So, bits per pixel... If you know how many bits there are per pixel and you know how many pixels there are, then you know how many bits there are in the total image. Okay, so calculating the file size for an image file, you multiply the width by the height. Yeah, in this instance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pixels wide, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is 10 times 10? What a challenging maths problem there. 10 times 10. If I thought this through, I wouldn't have used 10, but 10 times 10 is not 4,136, unfortunately. 10 times 10 is 100. I know it sounds crazy. It's not 2 pi either. I'm glad you guys aren't doing a maths test tomorrow, right? By the way, there are no calculators allowed in the exam, right? So you need to be able to do these sorts of calculations on paper. The other thing as well, you need to show your working, right? You can't just write the answer down and expect to get all the marks available. Now, if there was a question about calculating the file size of an image file, and I'm not saying there is, but if there was, there would be maybe in the region of 5 marks, right? And one of those marks would be for your final answer. The rest of the marks are going to be for showing your working. Okay? So the stages you've got to go through is this. Multiply width by height to find out the total number of pixels. Cool, there's 1 mark. Multiply the total number of pixels by the bit depth. How many bits per pixel are there? To find out the total number of bits in the image. Okay? Now, here's the important thing. We're not interested in the file size in bits. We're interested in the file size in bytes. To convert bits to bytes, you divide by 8. Okay? Convert bits to bytes, you divide by 8. But wait. Before we do that, we normally have to add on about 10% of our file size. So I've got 10 times 10 is 100, times 2 bits per pixel, that's 200. Why do I have to add on that 10%? What's that 10% of the file size represent? Metadata, mate. And what is metadata? Explain to me what metadata is, or give me some examples of the sort of metadata that might be included in an image. Yeah, extra info. So it's not info that makes up the file, it's info that contains information about the file, right? So in an image, who created the image? What file did they use to create the image? What is the file type? Does it use compression? What type of compression does it use? Okay, knowing the sorts of things that constitute metadata could help you get a couple of marks if there was a question on the paper which was something in the lines of, hey, give an example of the sorts of things that could be used in metadata. If you've got to go for tea, then that's cool. The video will still be up here by the time you get back. Okay, yeah, so be careful when you say size and resolution, they normally equate to the same things. It's pixel dimensions. So yes, you are right. The metadata would probably include that information. Okay. If it's an image which has been taken by a camera, it might also contain information about the focal length of the camera, the amount of zoom, the pixel density. You know, there's all sorts of different things that could be in there. Right? The most common ones are things like the dimensions, the program in which it was created, and the type of compression used, if any. Okay? So, once we have gone through that whole process, multiply the width by the height, multiply that by the number of bits per pixel, add on 10%, we will be left with a number of bits. Divide that number by 8 to get the number of bytes. Remember, there's 8 bits in a byte, so if you're going from bits to byte, you divide by 8. Simples, right? And then, if you've got over 1,000 bytes, you should probably express it as a kilobyte, so divide by 1,000, for instance. If you've got over 1,000,000 bytes, you should probably express that as a megabyte, so you divide by 1,000,000 and say megabytes. Does that make sense to everyone? I hope, I shouldn't have to go over this again because we've been over it a couple of times, but I just want to make sure that that does make sense in everyone's mind. Yes, says Ollie. Good. Cool, right. What on earth is that, Tommy? Don't know what that is. Anyway. So, what else have I got on my list of things? Bitmap image storage. Yeah, so being able to explain how bitmaps are stored, as in each pixel contains a single color. Those colors are stored in a color index, and each color is represented by a specific value of binary. Yeah, being able to explain that process. That's going to be useful. Should we go over the programming stuff, which I think would be beneficial to you? Does that sound good? Bit of programming. And then I'll throw it over to you guys, and you can suggest to me what you want to actually go over in addition to what we've already done. Program good? I'm going to throw open PyCharm here. Bear with. Cool, PyCharm. Can you all see my PyCharm window all right? Is this text large enough? Is that text large enough? You can be an honorary year 11. You can sit the exam tomorrow if you want, Ashton. Anyway, so we can see that's text. Right, so what is iteration? What does the word iteration mean? As a programming construct, what is it? What is it synonymous with? Bit more zoom. Okay. Zoom. How about that? Is that good? So iteration. What's iteration? Yeah, loops. Well done, Jenny. I'm glad at least one person is paying attention here. Okay, so being able to iterate through an array, right? In Python, how do we represent arrays? I mean, technically they're not arrays, but they're the closest thing with the basic Python libraries to arrays. What's it called? How does it look like? What is an array? Can you describe an array? Can you tell me how I would define an array in Python? Give me an example. Yeah, an array is roughly equivalent to a Python list. So let's say, for instance, I wanted to create... What am I going to create an array of? Yes, we define them using square brackets. What am I going to create an array of? No one knows. Any suggestions? Worst humans, okay. Right, so worst humans. Worst humans equals, and then we specify using square brackets, right? Everything that is in between the square brackets becomes part of our array. Individual elements in our array are separated by commas, right? So if we have Elon Musk as worst human, we can also have Jeff Bezos in there as well. Well, who else should we have? Hitler. He was pretty bad, right? Stalin was also pretty terrible as well. I mean, that's about all I can fit on. Anyone think of another awful person? Tommy Fallon. Okay. Put Tommy. Wicked. Okay, so let's say, for instance, what we wanted to do was go through this list of people and just print out their names one by one, right? There are multiple different ways of doing it. There's a Python-y way of doing it, and there's a more generic way of doing it, and both have their own relative advantages and disadvantages. Okay. Yeah, Tommy's on the right of Stalin. Yeah. So we will need a loop, right? What kind of loop do we need? I've nearly finished this. This is my last little nugget thing. So then you'll have my full and undivided attention, and I won't be chomping like a trough. Chomping like a trough? Chomping like a pig at a trough. Okay. Right, that's that done. What kind of loop are we going to need? Yes, a for loop. How do we know when to use a for loop and when to use a while loop? Type that in the chat while I go and get my next thing. That sparkling apple juice thing. Right, so how do I know when to use a for loop and when to use a while loop? For loop may need to iterate through. Yeah, so the for loop, when we know how many times we are going to loop. Yeah, with a while loop, it's when we don't know how many times we're going to loop. We're going to do it until a certain thing happens. You know, like you might say, I am going to punch you in the face 10 times, as an example. Or you might say, I am going to punch you in the face until your nose is broken, right? I mean, you might say those things, not actually do them, obviously. All right, so if we know how many times we want to loop, we use a for loop. We know how many times we want to loop with that list of terrible people, so we are going to use a for loop, okay? Now, I will show you the Python-y way of doing this, and then I will show you the more generic way of doing this, okay? So we have here, sorry, I'm just going to, yeah, that's fine. We have here for human in worst humans, right? What this basically does is it says, go through each individual item in the worst humans list. Assign that item to the temporary loop variable human. Right? So the first time we go through that loop, human will be Elon Musk. The next time we go through it, human will be Jeff Bezos. The next time we go through it, human will be Hitler. The next time we go through it, human will be Stalin. The next time we go through it, human will be Tommy. Okay? So what we want to do is actually do something with that information. We know what bits we are going to loop through because it's all the bits that are indented after that colon there. So we might just start off by saying print human. Okay? So let's just look at what's going to happen here. We start off here. We set up this list. Here's our list of worst humans, and then we say for human in worst humans. So we start our loop. The first time we go through that loop, human is equal to Elon Musk. So then we print out whatever the value of human is, which in this instance is Elon Musk. So we will get the printout Elon Musk. Once we reach the end of our indented code block, we loop back round to the top here. And the next item in the list is assigned to our loop variable. So human now becomes Jeff Bezos. Okay, so when we print human this time, it's essentially saying print Jeff Bezos. We then loop back around. There's still another item in the list, so human becomes Hitler. We then print Hitler. We loop back around. Human becomes Stalin. We print Stalin. We loop back around. Human becomes Tommy. We print Tommy. We loop back around. And now there are no more things in the list, so we skip over the whole indented block and do the next line. So for instance, we might have print all done. Exclamation mark, right? If I run this code now, you can see it has printed out Elon Musk, Jeff Bezos, Hitler, Stalin, Tommy, all done, right? Does that make sense? Now, obviously, what we could do is we could manipulate the things before we print it out. So we could do something like, I don't know, output equals human is a piece of ish, right? And then instead of print a human, we print output, right? So now when we run this, yeah, it lists all of those people as pieces of ish, and then it prints all done. Okay, so it's going through each of these lines in turn. Yeah, we could potentially as well at this point change. We could say human equals some sort of fish, and then after we've printed the output, we could then join on human. Now this is obviously going to look a little bit silly. But the point is that just because that variable has been set at the start of our loop doesn't mean we can't change it later on. Okay, that was a pretty silly example. Do we get what's going on here? This is the Python-y version of this. Yeah? Now, the more generic, less Python-y version, which also neatly works in pseudocode, is to iterate through using an index iterator. Okay? Can I delete this code here? Are we done with that code? Can I delete that? Am I all right to delete it? Yes, right. Cool, that code is gone. So we're still going to use a for loop to go through this, but instead of assigning a loop variable, right, we're going to do something slightly different. We are going to say for I in range. Now we could, how many items are there in the list? 1, 2, 3, 4, 5. We could say for I in range 5, right? And what that will do is that essentially creates a list which starts at 0 and goes up to, but not including 5. So that is effectively, that range 5 creates a list from 0, 0, 1, 2, 3, 4, right? But if we later decide to change the items, maybe we decide that compared to Elon Musk and Jeff Bezos, Hitler isn't actually that bad. We could maybe remove him from the list, and then there's a different number. We'd have to rewrite our code here to accommodate that. But we don't have to hard code those values in there. We can use the len command to specify the length of that list, worst humans. Okay, so what this is actually doing now is len worst humans. It will count how many individual items there are in the worst humans list. Okay, there's 1, 2, 3, 4, 5. So that len worst humans gets replaced with 5. And then the range is range 5. So it's going to generate that list from 0 up to 4. And then it's going to assign a new value from that list to I each time. Okay, so what we need to do in here, because we don't have that value human anymore, what we have to do is access the individual items in the worst humans array. We need to do something specific. If we just want to print out their name, we would print worst humans, and then we would put something after that. What goes after worst humans? So it's just going to pick out Elon Musk the first time round, Jeff Bezos the second time round. It's going to be the index, but what's the actual format of that? Give you a clue. The first time round, I is equal to 0. The second time round, I is equal to 1. Yeah, you're absolutely bang on, Ollie. Right? I. Yeah? If I print that out now, yeah, we've got worst humans, I. Run that. Worst humans, I. Elon Musk, Jeff Bezos, Hitler, Stalin, Tommy. Can we see how this is working, yeah? We've set up this list. We have set up a range of values based on the length of the list. And if I added someone else here, maybe Mr. Blobby. Remember Mr. Blobby? It's gone off the edge of the screen. But the great thing here is it will automatically add that on. So Mr. Blobby is there just underneath Tommy. Yeah. The actual, what's actually happening here is we are setting up this value I according to the range which is set up by the length of the list, right? So the first time going through, I is set to 0, which means this line becomes print worst humans 0, okay? The item at index 0 in the array is Elon Musk. So print worst humans 0 would print out the value Elon Musk. Then we loop back round up here, okay? I now increases by 1, so I is now 1. Worst humans 1 is Jeff Bezos. He is at index 1 in our worst humans list. Does that make sense? Yes, makes sense. Okay. Now there is a slight advantage to this method over the Pythony for human in worst humans, right? And that is the fact that we have access not only to the values, we also know the index that they are at as well, which means we could potentially, if we were writing like a bubble sort algorithm or something like that, we could find out what the next item in the list is. I'm just going to change this slightly for reasons that will become clear. Worst humans I plus 1. We now have access not only to the thing that we're looking at, but the next thing in line as well, right? So the first time we go through it, I will be 0. So when we print worst humans 0, we're going to print out Elon Musk. Then on the next line, it's going to say the next item is, and it's printing out worst humans I plus 1. Well, I is 0 at the moment. I plus 1 is 1. So it's going to look for worst humans 1, which is Jeff Bezos. So it will say the next item is Jeff Bezos. Then it loops back round again. I becomes 1. It's going to print out Jeff Bezos because that's worst humans 1. It's then going to look at worst humans 1 plus 1, which is worst humans 2, which is Hitler. It's going to say the next item is Hitler. Does that make sense to everyone? Look, you can see there it's worked. That's the reason why I put that -1 in there, because otherwise we'd get up here and we'd have an index out of bounds error. Yeah, we would get the index out of range error if we just used len worst humans, right? I specifically subtracted 1 from the value there. If I just get rid of that 1, yeah, if I run that, we will get that error. There we go, list index out of range. Yeah, so that's because on the last time round, I is 0, 1, 2, 3, 4, 5. I is 5 at this point, yeah. I is 5, which means that we're trying to pull out worst humans 5 plus 1. Worst humans 6 doesn't exist. Okay? So you're absolutely right to be on the ball and think, oh, wait a minute. If we're dealing with indices above what we're working with, we're going to run into problems. You know? So there is that. Does anyone foresee any potential problems being able to iterate through a one-dimensional array like that? Everyone's gone quiet. Amazing. Amazing. I love how talkative you guys are. So my next question for you is, what specific areas are you concerned about that you want me to tell you about right now? This is like last chance forum. Okay. There's going to be some of you that are thinking, oh, I don't know about this. I'd like to find out more about that. You know, this is your chance for me to tell you specifically about the bits that you want help with. So let me know either in the chat or the Discord, just say so that I can help you out. Right, calculating file size and storage space. At the very start of the video, we calculated the file size for images. That's the only one that you need to worry about. But if you want to think about storage space, let's go over that, okay? So calculating the storage space thing it's a slightly different approach. So bear with me a second while I get my yeah, where is it GIMP. Here we go. Let's say, for instance, you have 100 megabytes of free space. Yeah, apologies for my mouse artwork here. Free space, yeah. Right, we got 100 megabytes of free space. Look how free it is. So free, the Americans have tried to colonize. Okay, so let's say, for instance, we have a bunch of video files. Each video file takes up, I don't know, let's say 13 megabytes on average. Each video file is 13 megabytes. Here is the calculation for you to do. How many of these files can we fit into? I mean, that's kind of a horrible one, actually. Maybe I won't say 13. Maybe I'll say no. I will do 13. We'll do 13. How many? Yeah. Ooh, America. Go away. How many of these 13 megabyte video files can we fit into the 100 megabytes of free space? Go, do the calculation. 7. Are we agreed at 7? Yeah? What's 13 times 7? 3 times 7 is 21. 1 times 7 is 7. Plus 2 is 9. 91, right? Now, obviously, that will leave a certain amount of space free, right? If we've got 7 video files, that's taking up 91 megabytes of space, and there will be 9 megabytes free. And well done to everyone for not saying, 7 point, however many. Because that 9 megabytes is not big enough for one of these files. We can't store a portion of the file. It has to be the whole thing or none of the thing, right? So we can only fit 7 13 megabyte files into 100 megabytes of free space. Does that make sense to everyone, right? If you have a question on the exam, which is pretty much exactly the same as that, but with slightly different numbers, it's my hope that you should be able to know that big number of free space divided by small number of file size gives you total number of files available when you discard the remainder. Make sense? Connor using Internet Explorer, I think there. I think you might be behind by a few seconds, Connor. It's all right. Don't worry about it. Wicked. So that is that's that one. If I just have a quick look at the other subjects that were on there, system security, threats, and how to protect against them. We went over a lot of that in the lesson today, I think. If anyone wants me to go over those again, happy to do that. Networks, WANs and LANs, hardware. By the way, it's probably not worth your while at this stage looking at things like packet switching and The network layer model, we've done a lot of work on that, and I don't need to see any more evidence of that, so don't worry too much about that. The role of the operating system in multitasking, memory management, peripherals and device drivers, defrag and other utilities, virtual memory, calculating the file size and storage space, assigning variables, high-level and low-level languages, test tables and code maintainability, logic circuits and truth tables. Don't know if you want me to go over truth tables because we didn't quite go over that in the lesson. We went over the logic gates but not the truth tables, so I'm happy to do that. Bitmap image storage and metadata we did right at the start of this video. Iterating through arrays during for loop, I've literally just done that. So truth tables. People say truth tables. Are we good for? We want to go over truth tables, yeah? So let me just erase. Let the wind erase this like the memory of your kiss. There. Oops. Oh no. I erased the white as well. I mean, not necessarily a bad thing. What have they ever done for us? Right. Here we go. So. Truth tables. Let me draw you a logic circuit. Yeah, and then we can do some system security stuff. Let me draw you a logic circuit. Okay, we'll start off with something simple. How would you write that logic circuit as a Boolean expression? Oh, cool. Josh is in the past. I love it. Josh is in the past. So, yeah, it's A and B. That's A and B, right? Now, if I was drawing, or rather Q equals A and B. If I was drawing a truth table for this, it would take this format. Right? I would have a column for A, I would have a column for B, and I would have a column for Q. Obviously, these two columns over here are our input columns. These over here are our output columns, right? So the input always follows the same pattern, and it's like counting up in binary, right? We start off with 0, 0, we then go 0, 1, we then go 1, 0, and then we go 1, 1, okay? Those are our values. And yes, yeah, what you've got in the chat there, Nick, is absolutely bang on, right? The way that we read across is each row tells you the inputs, and you have to write down what the given output would be. Okay? So if we have a 0 here and a 0 here, it's an AND gate. 0 and 0 is going to be 0. Okay, if we have 0 and 1, it's better to write it like this, Alex, like that, because what you've put there, that is technically intersection rather than and, which I know behaves in a similar way, right? But it's not quite the same. So 0 and 0 and 0. 0 and 1 is also 0. 1 and 0 is also 0. 1 and 1 is the only way that we get 1 here. Right? That makes sense to everyone, yeah? Doing simple truth tables like that should be no problem. But wait, what if I was to tell you that simple truth tables are not the not what we're looking for? We're looking for more complex truth tables. In the same way that you won't be asked to draw a single logic gate, you'll be asked to draw like a compound logic gate. Yeah. Is there a difference? Yeah. And is Boolean algebra, and intersection is set theory. Just going to delete all this stuff. Right, going to draw another logic circuit here, and I want you to tell me what it represents. So we're going to have an A here, a B there, and a C there. Let's do this. What is that? Logic circuit. How would you write that out? Answers on a postcard, please, while I go and, hey, do you want me to grind some coffee? You want to grind some coffee? No one wants coffee. Ah, shame, shame. Not even for old time's sake. Oh, Nick demands coffee. Right. While you work out what that logic circuit represents, I'll go and grind some coffee and make myself some coffee, and then I will be back. Okay? Hope you're ready for this. Here it goes. Only a little bit. I'm just putting the coffee machine on. I'll be back in less than a minute. Hopefully I'll have lots of answers from you as to what that logic circuit represents. And then we're going to draw a truth table for it. So another thing that you might want to think about is what the truth table for that thing actually looks like. Right, what do we got? Let's have a look. A and not B or C equals Q. Yeah, that's absolutely bang on, right? This is equivalent to A and not B or C equals Q, right? And by the way, you don't need to know the specific symbols, right? You can write that just as A and not B or C equals Q, right? That looks terrible. Look at that horrible mess, right? So here's the thing, right? When we're writing the truth table for this, if we're writing the truth table for this, we need more than 4 rows, right? There are 3 inputs. How many rows are we going to need? Eight, yes. I'm just looking at that truth table here. Should we draw out this truth table? Wondering if I can make it any smaller. Right, so we're going to have an input for A, B, and C, and we're going to have... Now, with things like this, sometimes it's convenient to also have the interim thing. So you could have B or C, and then not B or C, okay? So I'm going to do that, B or C, and then not B or C, simply because it makes it easier for us to see exactly what's going on here, okay? So the actual answer that we're looking for is just the A, B, C, and Q, but the numbers would be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, and then 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Amazingly, I managed to fit all of that on the screen. Cool. So if we just look at B or C, well, B or C is true when either one or both of B and C. So the only time B or C is not true is when all of those are off. So that would be 0 and then 1, 2, 3, 4, 5, 6, 7 ones there. So not B or C is the inverse of that. So we have a 1 there and a 0. Have I messed up somewhere? Sorry, that should be a 0 there, shouldn't it? It should be a 0 there. A 1, a 0, a 0, a 0, a 1, a 0, a 0, a 0. Okay, so now we're looking for anywhere where this column here and this column here are both 1s. So we know that the first 4, because A is 0, the first 4 are also going to be 0, 0, 0, 0, 0. And then we've got a 1 there and a 1 there, so that's going to be 1. And then we've got 1s there, but all of these are 0, so they're all going to be 0, right? So our Q there looks like this. It is only 1 in this situation where A is 1 and both B and C are 0, which looks about exactly the same as what you guys have dropped there in the chat. Does that make sense? Being able to do more complex truth tables like that, same rules apply. Are you reasonably confident with the logic stuff? Yeah. Wicked. Now Nick wants to go over some system security stuff, so we can go over that. Specifically, the areas to focus on are threats to the system and how to protect against those threats. So if you just bear with me a second, I may be able to get something up for you here. I will also need to go and grab my coffee from my wonderful new coffee machine. It's very good. It's probably the best coffee machine that I've ever owned. I might go so far as to say it's the best coffee machine that anyone has ever owned. Obviously, I've not been able to test it against all of that stuff. You may have noticed that I'm rambling merely to hide the fact that it's taken me ages to find this particular resource, and you probably sat there thinking, what is this idiot doing? Why is he taking so long to find this? Is that the one we want to look at? That might be the one. I mean, yeah, okay, cool. We'll have a look at this. Presenter view. Get rid of the GIMP. There it goes. Get rid of the PyCharm. Cool. Right, here we go. System security. Social engineering. Can you explain to me what social engineering is? Are you rambling about rambling? Of course I am. Of course I am. Ramblingception. Yeah? Christopher Nolan's got nothing on me. He's back. Check this out as well. Mighty Morphin Power Rangers mug. That's right. So social engineering. Give me an example of some social engineering. What's it mean? What's the thing? What's it do? If you've been socially engineered, why is that bad? Getting information from others, using human emotions against themselves. Yeah, you make it sound like some dark Jedi stuff. But yeah, stuff like fishing and smishing and farming and vishing, right? The thing to bear in mind, right, the weak spot in any computer system is the humans that use it. Human people are weak bags of meat with electricity in them. That's what people are. They will be rendered obsolete. Do you need to learn all the ings? No, you do not. You do not, right? They all fall under the banner of social engineering, right? We're not going to watch that video, but if you are interested, I can drop that. I've dropped that in the Discord for you, so you can have a watch of that if you want to. Check out that ancient meme. Imagine that, right? I'm gonna maybe skip past quite a lot of this because, right, here we go. This is here are some ways to make sure that we can protect against some of the attacks that we might face. Okay, so one of the threats to the system is unauthorized access, right? Someone accessing your computer system when they are not supposed to be able to access your computer system. This is bad. How do we protect against that? With a secure password, right? What is the easiest way of making a password secure? And why secure? I mean easy for a human to remember, right? Because if a password is difficult for you to remember, it's not secure because you're more likely to write it down, right? So easy for a human to remember, but difficult for a computer to crack. Can you give me an example of a secure password? That's reasonably secure, Nick. The danger there is that it's a single word from the dictionary, right? It does have a combination of uppercase, lowercase, symbols and numbers, which makes it good because that increases the amount of entropies, which would mean that a brute force algorithm would take longer to crack it. What would make that more secure would just be simply adding another word. Right, so instead of trilogy _214, if you had just a completely unrelated word, I don't know, trilogy Philistine _214 or something like that. That, Alex, is not an example of a secure password, okay? Because it's difficult for a human to remember, okay? Not secure. You are more likely to write it down. Okay, so combination of long broken up words with special characters, so as long as you've got a mix of uppercase and lowercase and digits and stuff to increase the range of characters that could be in there and a long length of your password, more than 8 characters, ideally 16 characters, right? When I was in high school, my password to the computer systems in high school was Creeping Death. Right, it was. I was a bit of an edgy Metallica fan, and "Creeping Death" was my favorite Metallica song at the time, and it was a long password, and I thought I was some sort of cool edgelord by typing in "Creeping Death" to log on to my computer. Right, I wouldn't use that password again because I've told you all what that password was. Right, but. It's a reasonable example of a decent, capital C, reaping, capital D, eath, creeping death. So let it be written, so let it be done. I'm sent here by the chosen one to kill the firstborn Pharaoh's son. What a song, man! What a song. Anyway. The other way of making sure that even if someone gets your password, that they are not able to access your computer is two-factor authentication. Now, I've been over two-factor authentication multiple times, but has anyone got two-factor authentication set up, or can you explain what two-factor authentication is? Yeah, I've got it on Steam. I've got it on my Epic Games account. I've got it on my any games accounts that I've got. Origin, even though I only use that for Mass Effect 3. Adds another layer, such Google Auth. Yeah, so the idea is you type your password in. It doesn't let you in until you have also confirmed it with a separate device. Yeah, so it might be your phone. It might be that they send an email to you. right, with a code that you then have to type in. It might be that they text you with a code to type in. It might be that you have to use a separate app like the Google Authenticator, which has a code which resets every 30 seconds that you need to type it in. So the idea is that if someone gets your password, they still don't have access to your two-factor authentication, you will get an alert saying someone tried to log on with your password. If that wasn't you, change your damn password. Yeah. The other thing, lock and key security. What do I mean by lock and key security? How will system security come up? Probably in a question along the lines of identify threats to a system and specify how you protect against those threats. Right? Yeah, lock your computer up in a physical contained area, right? If your computer is not connected to the internet, that's fine. You know, no one from outside will be able to access it, but people on the inside that can access that computer will potentially be able to cause damage. So you lock it up in a room where people can't access it. You know, think about the technicians' offices at school, right? They have keys to that. We don't. You know, none of us have keys to those technicians' offices. Now, the doors have been open because of COVID, but you can guarantee that if there's no one in there, those doors are locked up tight. Okay? So, yeah, we've gone over secure passwords. We don't need to know about dictionary attacks or brute force attacks at this stage. I will just open my second thing here. I've got something about malware, right? You should ideally be able to distinguish between the various different types of malware, right? So being able to tell the difference between a virus and a worm, it's a subtle difference, right? But it is useful. They're both the same. They are both malware, and obviously we can protect against them in the same way. What would we do? What would we do if we suspected that our computer system was at risk because of viruses? How would we protect against it? Any ideas? Right. I'm just going to address something that Tommy has said here. He put firewall stroke antivirus. That is not correct. Antivirus protects against malware. Firewalls do not protect against malware, right? If you identify a threat to the system as malware and you say how to protect against it, firewall, 0 marks. You miss out. Okay? Firewalls do not protect against malware. Say it with me. 1, 2, 3, so your parents can hear. Firewalls do not protect against malware. Chant it like a cult. Firewalls do not protect against malware. Okay? Antivirus is the only thing that protects against malware. Okay? If you're already infected with a virus, your best bet is to restore from an old backup and then install antivirus. Installing antivirus after you've already been infected, it can be a bit of a risk because the viruses can sort of like anticipate that and say, yeah, everything's fine, don't worry about it. Okay? It helps to prevent viruses getting onto your computer though, right? No. How does it? Viruses don't seep into your computer through the internet. That's not how it happens, right? The firewall is not going to stop you because, like, if you get a virus from a website, the firewall isn't going to stop that at all because it's come in through port 80, which is open for your HTTP traffic. If you get a virus off a USB stick, a firewall ain't going to protect against that. You know, if you get a virus sent to you via email, the firewall isn't going to make a blind bit of difference. It's already on your system. Yeah? So the only malware that you could reasonably say that it's going to protect your system against would potentially be a worm, right? If a worm is duplicating itself on a system and tries to spread to your system across a network, but guess what? Those worms are going to propagate across open ports, right? And they are not there. They are going to say, right, any open port, don't care what it is, any hole's a goal, right? That's what they're going to do. Yeah. And Nick has asked a very pertinent question here. So what's the point in a firewall then, right? The firewall protects against a far greater threat, which is a human attacker, right? If you have ports open, yeah, potential attackers can access your computer through those open ports, right? And it might be through a specific connection attack. So my Linux box, it has SSH on it so that I can access it remotely from outside. Hackers try to get into my box through that all the time. So what I do is when I don't need to access it, I will set my firewall ports to block the port that my SSH comes in on. Okay. They might also see an open port. Like port 80, for instance, is going to be open for your HTTP traffic. What they might try and do is force their way in through that port, right? But it's not viruses that are doing that; it's actual people. The other thing as well that the hackers might be sending is denial of service attacks, right? Which might all come in on specific ports or port ranges. Yeah. The other thing as well that firewalls do, they don't just prevent data coming in from the network onto your computer. They prevent data from going out from your computer to the network. Why do you think that might be necessary? Worms potentially, yeah. I mean, that's one thing. But like I said, worms are generally going to sort of try and propagate across any open port. They're not fussy, right? Stops the rest of the network getting hacked? Not necessarily, because I mean, do you mean like if the attacker accesses like one node, physically accesses one node on the network and tries to access the rest of the network? I can, sure, yeah, I can see that. But what I'm talking about is like the firewall sits between your private network and the public internet, right? So data cannot be taken out of the computer. Yeah, and why might that be an issue? Why might it be useful to not have that data leave the computer in the first place? You're getting very close to an answer here. Yeah, data theft, right? Another thing that hackers are going to do is they are going to use things like keyloggers and stuff like that. They might try and access your personal files and things like that. So specific bits of data, you don't want that leaking out onto the internet. Another thing is if you are running a company that has many trade secrets and things like that, you probably don't want those trade secrets to be leaked either. Therefore, you prevent those things from coming out. Okay, does that make sense? So viruses and malware, we protect against them using firewalls, right? Do we know about data interception? Do we know about these things called man-in-the-middle attacks? Being a teacher, yeah. The Data Protection Act. Obviously, the Data Protection Act says that we have to make sure that any data that we keep is kept safely, so that that data can't be leaked. You know, and it's not necessarily protecting it from outside forces. There might be corrupt inside forces that want to sell that data. Not that I'm saying that any teachers would have the level of competence to do that. Yeah, rerouting your data, right? Here's Alice. Alice is sending a message to Bob. Mallory is our naughty man in the middle, right? Intercepts that transmission. Now, there's a number of things that could happen. Obviously, Mallory could read that information and do whatever he or she wants with that information. But what normally happens is Mallory will change that information subtly before passing it on to Bob, right? And then when Bob responds, what Mallory can do is reroute that information somewhere else. Okay, so intercepting that data and being able to read that stuff. How do we protect against that? Is that against the CMA? Yeah, it's against the CMA. Yeah, don't do it. it's data interception. It's not. It's not something that you should be doing. It would be like sort of like listening in on your neighbour's conversations or something. Putting a cup up against the wall. Have you ever done that and listened to their arguments? Not that I've ever done that, of course. At least not since I moved out of Coventry. So digital signatures is one way to ensure that the messages we receive have come from the person that says they have sent it. Now look up here, right? We can see, you can't see because I've cut out my address bar, but if you have a look at the top of your web browser, there should be a little icon with a padlock in it. If you click on that, you will get some site information. It will tell you the connection's secure, and you should be able to view the certificate. Okay, I can see that website identity here is docs.google.com. I can view the certificate. It was issued in the US, in California, in Mountain View. The organization, Mountain View, sorry, not Mountain Dew. The organization is Google LLC, right? It's got that whole bunch of data in there, so you can verify. Yeah, this website that I'm on, this is actually from that place, right? Now, what happens when you guys send a message out from the school computers onto the network is our server unpacks your packets to sniff them, to make sure that you're not up to no good, and to make sure that we're keeping you guys safe online, right? And what it then does is it repackages the stuff and sends it on. And this can cause certain problems because when the data receives at its destination, the servers can say, wait a minute, something dodgy is going on because this packet has been opened at some point along the way. You may have been the victim of an attack. That's what happened with us trying to install individual Python modules, but we might have had a workaround for that. Okay. So digital signatures. How do we prevent the information, if it is intercepted? How do we prevent that information from being read in the first place? How do we prevent that information from being read in the first place? Yeah, Mountain Dew, my favourite place. Not necessarily a VPN. There's a specific thing that a VPN does, though. Yeah, encryption. The thing to bear in mind, right? A VPN is not necessarily a security measure. Yeah. People on YouTube will try and sell you VPNs, right? They are being paid by NordVPN to try and sell NordVPN subscriptions. So they're going to say, if you do anything online, you need a VPN because otherwise, right? You probably don't need a VPN, right? What a VPN does is it creates an encrypted tunnel through the internet, which is accessible by your traffic only. All it really does is hide your IP address, masks it with a different IP address. VPNs are very useful if you want to appear that you are located in a different part of the world. For example, if you want to watch US Netflix, but Netflix says, wait a minute, you're in the UK, you can't access US Netflix. If you use a VPN and tunnel through a US IP address, then obviously it can see, oh, cool, you're in the US, right? But I don't want you guys thinking, oh, if I use a VPN, then everything I do online is secure, because that's not the case. Okay? The VPN is only secure between like your computer and the access node that accesses the public part of the internet. Your data can still get intercepted after that. Does that make sense to you? Am I good? Encrypt it, says Cheese. Yes, you are absolutely correct, Cheese. Cheese. Cheese is pretty awesome. I miss cheese. Single tier. Do we know what a denial of service attack is? A DOS attack. Yeah? Do we know what a DOS attack is? Can you give me an example of a denial of service attack? When someone makes tons of requests onto one system, yes, so many requests that the system cannot deal with it, right? And a traditional denial of service attack, all of those requests come from the same system, right? So it'd be like me saying, give me the thing, 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 give me the thing. And it gets to the point where you're like, oh, God damn it. You know, my head's going to explode. In fact, I wonder if I can find that... does this exist here? I forgot to submit the thing on thing. Yes, it is there. It is there. Old school. Let's kick it old school with some Bart Simpson, right? Whoops, didn't mean to do that. Have I messed it up? Oh no, I've messed everything up. I've messed everything up. Bear with me a second. Oh, God damn it. I'm so sorry, everybody. No, I've ruined everything. I've ruined everything. I assure you I'm a consummate professional. There we go. There we go. Right, I meant to click that button. No, God damn, I did it again! I'm so sorry. Right, I'm going to get the right button this time. It's that one, yeah? Did it. Did it. I'm not a boomer, I swear. Right, this is what I was going to show you here.
No problemo. Where's the can opener?
It's in the second drawer from the right. No. The other one.
Oh, I got you. It's broken, Mom. Mom, it's broken. Mom, it's broken. Mom, it's broken. Mom, it's broken. Mom, it's broken.
I don't think that it's broken.
Now, I think Marge Simpson has the patience of a saint. How many of you guys have annoyed your parents to the point by just repeating something over and over and over again until your dad gets drunk and hits you and then leaves the country for a few months and then your mum is in floods of tears every single day, but you still have to make your own way home from school and make your own dinner? Maybe that's just me. But have you ever been in a situation where you've gone on and on and on and on and on and on and on so much that their brain has just exploded and into blind, ugly violence? Have you ever been in that sort of situation before? Right? That is essentially what a denial of service attack is to the server. Right? It's loads and loads and loads of requests, so much so that the server buckles under the pressure. How do we protect against that sort of thing? Filter in the requests. Yeah, give me an example. How might we decide to filter these requests? What limitations might we place on them? Block the IP address. Yeah. If you detect that multiple requests are coming in from the same location within a certain time frame, you say, nope, you're banned. Get the F out. Yeah. It's sometimes known as, well, I'll give you a clue. Can you remember what it's called? Here's a clue. And what's that clue hinting at? What's this? It's not flooding is essentially, yeah, flood defenses, right? A flood defense is that monitoring and blocking. Now, a standard denial of service attack, is reasonably easy to spot and block because it's like, oh, same IP address, get the hell out, right? But The distributed denial of service attack, also known as a DDoS. This is a little bit more tricky to deal with. And the reason is it's not just one machine sending tons and tons of requests. It's a whole ton of machines all targeting a single machine at the same time. Right? The diagram that I have here. Do you remember when this happened? Do you remember every GCSE student in the UK trying to get onto Hegarty Maths at the same time? And the Hegarty Maths server was just like, ugh! Right? If all of those requests are coming from various different machines, it becomes difficult to be able to block them all, right? But more sophisticated flood defenses are the way to avoid that. Now, the thing with DDoS attacks, it's normally not like lots of machines with individual users. Normally, those machines are part of a botnet. Right, that is a network of sort of zombie infected machines which have they're listening out for a go signal from a nasty hacker who says, yeah, go. And what happens is all of those machines, probably without the user's knowledge, will then start sending those DDoS attacks, etc., etc. Hello, Alex. Good to see you. Good to see you. I'm glad you decided to tune in. I hope everything's going well. I'm sure you remember all of this stuff from last year. How do you know whether your machine is infected? You run your antivirus scanner and it tells you. You know, that's why we need to make sure that we've got those antivirus programs on there to protect against those sorts of things, right? Da-dam, dam, da-dam, dam, da-dam, dam. Code injection. You don't need to worry too much about the specifics of code injection, right? But the idea is that you inject some code into like a data input box, and that code is then executed. I can give you a reasonable example here. If we go to, hang on a minute, let me find the. See if I can find the thing here. This is the website. In fact, let's plonk that up there. Right, so don't know if you can see this. This is a website called Alert One to Win. I will drop the link in the Discord and in the chat down here as well if you want to have a go at this. So the idea is this JavaScript has been written in such a way that it is exploitable, right? The idea behind this game is that you've got to type in the code into the input box, which will allow you to execute the command alert1, right? And there's multiple ways you can do it, but if you have a look, if you type anything in here, you can see what the console output is, because the function is basically returning all of this stuff here, yeah? So it's returning console.log blah, 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 right? So what we could do, if we close that script tag here, well, if you look now, what's happening is it's returning script console log and then closing the script there. Yes, very good, Tommy. And then we can essentially execute our own command there. Okay, and then in theory, what have we done here? Error, literal not terminated before end of script. Nope. Where is that? Why doesn't that work? Because I need a semicolon there. That should work, right? Oh, I see what's happened there. I'm hoping that my terrible sort of nonsense that I'm typing in here is not like making you think that I'm an idiot. Literal not terminate before the end of the script. Don't know why. But anyway, the idea here is that you can exploit the input in order to run your script. So that is supposed to be doing... Oh, I know. Maybe we should just do this. Script. Like that. Cool. And then... That work? That doesn't work. Anyway, I've made myself look like a total idiot by failing at the very first level of this game here. What I effectively want to do is... Nope, not that. What is it returning? It is returning script console.log blah 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 close script. So if I type that in, it's going to add whatever I type in there. That should close that, and then that should close the script there. And then what I want to do is open a new script tag, right? And then alert 1, and then close the script tag, and boom, there we go, I did it. Okay, so fairly complicated. There's probably way easier ways to do that. That took 38, and I probably didn't need 38 ways to do it. I could probably actually get rid of all of that stuff there, and it would, yeah, that would still work, right? But the point is, yeah, okay, that would also work, I guess. So what have you done there? You just opened the bracket there. Yeah, I think you do need to still close the script tag like that. Okay, that'll do it. Okay, but anyway. So you get the idea, right? That's what code injection is. The way to protect against code injection is by sanitizing your inputs, right? So rather than just straight taking whatever the user types in, what you would probably do is maybe convert these brackets, like maybe remove the brackets, strip out things that look like code. If you allow the user to type in HTML, for instance, strip it out. Replace that less than sign with an ampersand LT, for instance. Yeah, that's the thing to do. I'm just going to try out Ollie's thing here. What is it? He did that alert 1. There you go, that'll do it as well. Okay, and so you can see what's actually coming out here. Okay, so anyway, that's that. Don't need that. Okay, I don't really think there's much else to go over in terms of network risks and how to deal with them. We've been at this also for X amount of time, 1 hour and 35 minutes allegedly. So are there any other bits that you want me to specifically go over, even if it's just a small bit, or you just want confirmation that what you're doing is correct? Anyone want to comment or question? Or laugh at me for failing such a simple code injection task? They're all on Google Classroom, Tommy. I can go over them if you want. System security, threats and how to protect against them. Networks, WAN versus LAN and hardware. CPU components and their function. Role of the operating system in multitasking, memory management, peripherals and device drivers. Defragmentation and other utilities. Virtual memory. Calculating file size and storage space. Assigning variables. High-level versus low-level languages. Test tables and code maintainability. I don't know if you want to go over code maintainability briefly. Logic circuits and truth tables, bitmap, image storage and metadata, iterating through arrays using a for loop. Networks, I mean, in terms of the network stuff, it's literally, do you know the difference between a LAN and a WAN? You know, do you know what hardware is used on the network? You know, and didn't we go over that in the lesson? So, what is the difference between a LAN and a WAN? Yeah, code maintainability. Wicked. I'll go with that. I might bring up PyCharm, actually. Boom. There we go. LAN is local network over a single site. Yeah, that's right. And WAN is obviously over a large geographical area. So maybe there's a network in Scotland, there's another one in Wales, and there's another one in Outer Mongolia. But they're all connected using a private network that is a WAN. What kind of network would you have in your house? Cool. You're probably good to answer that question then. As long as you know what a router is, as long as you know what a switch does, as long as you know what a network interface card is used for, you're all good. Yeah? Yeah, in terms of the personal area network, obviously that's just all in a very small area. In your house, if you're networking things in different rooms, it's going to be a LAN. Yeah. Right, should we go over code maintainability then? Right, I'll tell you what, let's delete that code there. Let's write a program. Cool. What's this program going to print? What's this program going to print out? Let's run it and find out, shall we? Doesn't print anything. What if I do -1 there? Oh, cool! It prints out 1. Wicked. Let's just change it to that. Maybe. No, cool. We got loads more numbers, right? The reason it's not an error. This is all valid code. This is valid code. But the thing is, it's so difficult to see what's going on here. Okay. So what would be better? Is if we wrote the code out something like this, at least better for our understanding, right? One way of making the code maintainable, right? When we say code maintainability, we mean how easy is it for the person that wrote the code to understand it like a week later? How easy is it for someone who has never seen the code before to read and understand, right? And if you just give them something like this, or one of Alex's annoying Lambda functions that he seems to love so much, right? They're going to be like, what? You know. But what we could do is something like this. we could say output. Actually, no. I'm gonna use a equals empty string, and then I'm gonna say for I in range 100. Now you should be able to spot something that we've just seen up there. Yeah. We are now gonna say if I raised to the power of 2 mod 3 is 0, a plus equals I, yeah, and then print output, print a. All right, if I run that program now, we get an error. What have I done? A plus equals string I. If I run that now, look, we get identical output, right? These lines here give exactly the same output as this single line here, right? Which of the two, if I was to say to you, can you analyze this code and work out what's going on, which of these two blocks of code is going to be more likely to be easily understood to you guys as intermediate Python users? That's not a bottle of wine, by the way. This is the amazing sparkling apple juice. Yeah, the second one, right? The second one. Why the second one, though? What is it about it that makes it easier to see what's going on? Yeah, the indentation is one thing. Having it on multiple lines is another one, right? We can see that all of this stuff is part of that for loop. We can see that this line here is part of that if statement. Yeah, so the indentations make it easier for you to easily see which code belongs to which statements, right? There are two ways that I can make this even more readable. What are the two ways that you can make this even more readable? How can we improve the maintainability even more just with these? Yeah, comments would be the first one. Okay, so maybe I could say something like set up an empty string for the output. And then we can say loop through 100 times. Yeah, and then we could have maybe something like if I squared is divisible by 3, then concatenate it to the output. Okay, and then down here we can output final string. Right, just add in those comments instantly allows us to properly analyze exactly what's going on there. Now, ordinarily you wouldn't necessarily need a comment for each line like that, right? But having those things in place, certainly at the level that you guys are working, makes it better. Yeah, don't worry, list comprehensions get very, very nice. Once you understand what's going on there, list comprehensions are wonderful things. Yeah, don't be afraid of them. I'll try something out here. I don't think this is going to make a blind bit of difference. I just want to double check that. Yeah, that's fine. That's fine. Right. So anyway, There is one other way. There is one other way that we can improve the maintainability of this. Well, there's actually two other ways, but there's one other way specifically with this example that I've got here. Better variable names, yeah. What would be a better variable name for A? Output, yeah. Output or output string. Like that. Now, you'll notice that what I've done there, I've just changed output string there, and it obviously hasn't changed any of these, but check this out. Pretty cool, huh? Did you see what happened there? Let me just undo that. Yeah, if I rename a variable, call it output string in PyCharm, right? You get this little thing at the side here. If you click on that, it will allow you to rename all instances of that variable that you've just renamed there. You click on rename. Found occurrences in comments and strings while renaming A to output string. Would you like to rename them as well? Yeah, rename with a preview so you can see these individual things. You can step through each individual one, or if you're happy with it, you can just say, yeah, refactor that whole lot, boom, and now it has changed all of those A's to output string. Yeah, that can be very useful. It's a very useful feature of an IDE. Okay, so obviously output string is much better to understand there. Yeah. Cool. The only other way that you can improve maintainability, yeah, the only other way that you can improve maintainability that you need to know about is through use of functions, right? If this whole thing was inside a function, so for instance, if we had def print squares or something like that, yeah, and then all of this stuff is inside that there, yeah, that improves maintainability because it means that if we need to do all of this stuff again, we can just call the function. And if you have your things broken up into functions and you call the functions from various different points, it means that if something goes wrong with that particular code, right, you fix the function and it fixes all of the occurrences where that stuff has happened. So if there's a single bug and it happens multiple times whenever you're doing the same thing, right, if you used functions, then you fix the issue in that function. It fixes it all across the board. It also makes it easier to track down the bugs in the first place, right? Because everything is set up with specific functions for specific tasks. So if that one specific thing is not doing what you expect it to do, you know which function is responsible for that, yeah? And by the way, what we can do with functions in Python, if on the first line after defining a function you put 3 quotes and then hit enter, it will give you what's called a docstring template, right? What you usually do here is you say prints out the value of x squared for the range x equals 1 to 100 if x squared is divisible by 3. Right? And usually return none. Right? Usually what happens is if you've written a decent docstring, you probably don't need like specific comments all through here. Now here's another thing as well, right? If I now call print squares, if I mouse over that, you'll notice. Can you see that? No, you can't see it on your screen, but I can see it on mine. When you mouse over it, it prints out your docstring that you've just written. right? So when you are using your IDE, you can have the doc string that you've written as a tooltip to remind you of what that function does and how it's supposed to be structured. Okay, so doc strings are another way of improving maintainability. Not all programming languages support doc strings though, but it's kind of like a function, a comment for the entire function with a few extra bits there. Okay, are very long variable names bad? Generally, yes. I mean, like if I wouldn't want to have a variable name like number of times Tommy has jumped out the science room window, as an example, equals. Yeah, I wouldn't want a variable name that long. In fact, it's going to moan at me here. Oh no, that's just because I haven't put 2 blank lines after the function definition. But the thing is, if you're using an IDE, generally speaking, it doesn't really matter how long your variable names are in terms of needing to type them out. Because look, if I just start to, oh look, cool, I've typed in NU and then I can press the tab key and it auto-completes for me. But what would be better than number of times Tommy has jumped out the science room windows, we could put, I don't know, TF defenestration, yeah, or something along those lines. Let's just quickly refactor that. TF defenestration. Yeah. It's better to have more concise variable names, but you don't want to go too small. It's a balancing act. Yeah. You want variable names which are descriptive enough for them to be distinguishable from other variable names, but also you don't want to go too long because that can clutter up your code. The other thing as well that you should avoid doing, and this is more a style point than anything specific. If you have a, that's not defenestration. If you have a variable, a parameter which mirrors a variable name from outside, yeah, what's going to happen is there's the potential for you as the programmer to get confused. The program itself will not get confused, but generally, if you have a variable outside your function which is string and you want to pass it as a parameter, you would have something like I_string, so that you can say, hey, this is the input, or P_string saying this is the string parameter. But that, like I said, that's not really something that you need to know for this test. That's just me pointing out a style issue there. So ways to improve maintainability: we've got comments, we've got indentation, we've got sensible variable names, we have got the use of functions. Yeah? Is that all good? Is there any other bits that you guys want me to go over? Briefly go over network hardware. Okay, cool. I'll give you a whistle-stop tour of network hardware. Just bear with me a second while I pull up the presentation. It really is going to be a sort of like quick one and done sort of deal here. Okay, so let's go to present a view there, and I will. Boom. Right, network hardware. Here we go. This thing is a router. A router is used to connect multiple networks together. Now, it is found in most people's homes, and most people think the role of the router is to connect your computer to the internet. That is not true. The router connects 2 different networks together. Now, normally that means your home network and your ISP's network. right? Your ISP's network allows that connection to the internet. You see what's going on? So the router is what allows you to connect to the internet, but what it's actually doing is it's connecting your home network to your ISP's network. Most routers also have a built-in switch or wireless access point as well. That's what these antennas here are there, right? Boom, there's a router. I believe this presentation is shared up on the Google Classroom, so you can have a look at that. This is an example of a switch. This is a rather large switch used in a sizable section of a LAN. The switch is used to connect different nodes together on a star network, right? And also with the switch, when data is sent from one node to another, the switch routes it exactly to the node it wants to go to, right? So if I have a message for node number 5 and I am node number 1, it comes out from me, it goes to the switch, and the switch sends it directly to node number 5, yeah? As opposed to a hub, this is a hub, right? The hub will send out data to everything that's connected to it at the same time. Now, from these crap animations that I robbed off an ancient website, you will notice that if this machine here is sending a signal, it then gets broadcast to every single computer, which means no other computer can send a signal at the same time. Whereas with a switch, because it's more intelligently routing this stuff around, it means you can have multiple transmissions at the same time, provided they are not trying to use the same computers. Okay, so both the hub and the switch connect all the nodes together on a network. Now, interestingly, on a star network, the center of the network is a switch. Technically, if you connect everything together with a hub, it's not really a logical star network. It's a physical star network, but it's a logical bus network. But you don't need to know about that. Okay, as long as you know what a switch and a hub is. What else we got? The NIC, the Network Interface Controller. This thing takes the stream of ones and zeros, converts them to physical signals, either electricity or bolts of light or radio waves or whatever. Okay, every computer on the network requires a network interface controller, so it can receive the signals and convert them to binary, so that it can convert the binary signals to electrical signals and send them out. Okay, this is the link layer device here. There we go. And obviously transmission media, the different hardware that you will need. The one that you most frequently see is the twisted pair RJ45 cable. Pairs of cables, one for send, one for return. They are twisted together to remove or decrease the amount of electrical interference that happens. There are also copper coaxial cables, which you rarely see on your home networks. They're more likely to be used for big backbones, although more and more we are using these things, fiber optics, which do not send electricity pulses. They send pulses of light. They are way faster than your electrical cables, but also more expensive. We've seen the video on total internal reflection. And the other transmission medium is the air, right? Radio waves are sent through the air. The radio waves are sent across what's called channels, which is ranges of frequencies. The channels mostly overlap. So it's important for you to set your Wi-Fi access point to broadcast on a channel which doesn't already have a lot of traffic on there. You can get Wi-Fi analyzer apps for your phone. And that's it for network hardware. Boom. Yay, we did it. All good? Does that help you out, Ollie? Bear in mind, this presentation is on the Google Classroom, so you can go through it on your own and maybe do a little bit of extra research as well. But really, there isn't an awful lot to say about those things. You don't really need to know an awful lot about that. We've been going practically 2 hours now, I think. Yeah, literally dead on 2 hours. So does anyone have any final things that they're concerned about or want me to go over? Sensible suggestions, please, Alex. I can see you typing. He stopped typing, right? Does anyone have any specific things they want me to go over? Are we good? I think we're good. I think we're good. Okay. All that remains. I can see Ollie is typing something. I wonder if it is a question or just him saying everything is great. Yep, thank you. Don't think so, thanks. Right, okay. So all that remains to say is obviously get a decent night's sleep. Make sure that you get a good breakfast in the morning. You'll be amazed how much difference that makes. This morning I made myself some porridge. It's dead easy to make. Half a cup of porridge, a little bit more of milk. You put it in a pan, right? You heat it up until it's like just bubbling a little bit. Then turn the heat down for a couple of minutes. Stick it in a bowl with a bit of almond butter and some maple syrup. Amazing, right? And that'll keep you going all morning. If you don't have porridge, make some cereal. You could even, if you just have bread, make some toast. Have something for breakfast, right? It will make a big difference in your life, right? The other thing as well, when you're faced with the exam, I would highly recommend reading through the whole thing first before you begin. Make sure that you answer the questions strategically. Choose the questions you are most confident with first. Answer them first, right? Pace yourself. 1 mark per minute. If you're on a 2-mark question and you found yourself stressing over it for 10 minutes, you are wasting your time. It is not worth spending 10 minutes on 2 marks, right? It is set up there. It's a 90-minute exam and there are 80 marks available, right? So if you pace yourself 1 mark per minute, it means you've got 10 minutes left to go back and double check your answers. Make sure you answer every single question, even if you're unsure of the answer. A question that you leave blank is guaranteed to be 0 marks. A question that you attempt to answer, right, there's an infinitely higher chance that you'll gain some marks. You still might not get anything, but you know what? If you put something in there, you've got a chance. If you don't know how to write a function, if you don't know how to write a program, then write the bits that you can write. Remember, there's 6 marks available for some of those programming questions, yeah? If you write nothing because you're like, well, I don't know the order that these things are supposed to go in, right? You're missing out on tons of marks. If you know that something has to be output, write that thing down, right? If you know that a procedure has started and at some point it needs to have the end procedure marked, then write that end procedure in there somewhere, right? Are we putting our names on it? No, you guys are just going to put your candidate numbers on there because they don't trust me to not be biased, even though I'm just going to... you know me, I'm cold and heartless, and I don't care whether I make you cry or not. I am going to award the marks that you have earned and deny you the marks that you have not earned. But still, you're just putting your candidate numbers on there. All right. I don't think there's an awful lot left for me to say other than best of luck. I know that you can do it. Remember as well, the score that you get on this test is not your final grade. That's being sort of worked out. The test is sort of like, you know, forming my evidence base for your final grade. Okay? Hopefully you're feeling a bit more confident now than you were this time sort of 3 weeks ago. Look forward to seeing your happy smiling faces tomorrow morning after it's all done. I believe this is your last exam as well for a lot of you as well. So, you know, but you can breathe a sigh of relief after that. Okay? Thank you, everybody. I shall see you all tomorrow.